Alright, so now in this video I gotta show you that I have my two switches powering. I'm gonna take this out. Alright, so I got switching the top coils, and then a switching the bottom coils like I showed in my last video. So now I got a constant torque, and there's a lot of torque now, like quite a bit. Going through 3 coils per side, but I have it running just on this capacitor bank here, and it's these capacitors like I've showed in my other videos. It's 3 by 3, so it would be a 12 or be a 1300, be like a 1400 volt capacitor bank by 220 microfarads. But that's the current charge. I'm just charging it with my battery pack here, so it charges really quick with this battery pack, which is nice. So that's the amount of drain that it has, just running with no load. But I will put a load to it, and it's going to be slowing it down as much as I can, as much torque I can pull from it. And that's how fast that drains. And I'm putting quite a bit of a load to this. I go from the outside of the rotor, it's a little easier to put a load to it. And then I'll measure the amount of current that it pulls. I'm going to have to swap my leads around a little bit here. Alright, so now we know what the voltage is when I charge this up, but obviously it's constantly draining. Or I could just leave the lead on, but I'm not going to leave the lead on. Alrighty, now I'll measure current. I blow on my fuses several times in my meter just by forgetting to switch my wires around. I go to check the voltage of the battery and I end up blowing the fuse because I forgot to switch it. Alright, now I'm gonna put this around one of these wires. Doesn't matter what one, at least I don't think it would. This is always tricky. Let's get an alligator clip, if that'll even help me. Alright, come on. And that is just barely hanging on there. Alright, so we got it in the milliamps. Gonna go to this capacitor. And now we're gonna be showing how much current it's pulling. Charges it back up. Ah, screw it. Let's just leave it on for the current test here. Alright, so we have max, basically just running off the battery now. But that's the amount of current it's pulling with no load. Now I'll put a load to it. So that's how much current it pulls. This is taking a lot of force. Like, you could see the rotor bumping up and down from the coils, pushing and forcing the magnets to spin. And that's only, if you go to buy, the voltage of the battery pack is not at 1000 volts anymore. Notice it's dropped, so it's like 965, 970. But if you take, the voltage drop a little bit from this load, say 960, and you go to, multiply that that current to that voltage, that's under 2 watts. And this is a lot of torque off of 2 watts. That's a lot of torque. I barely can stop it. I'm squeezing as all I can right now. This, now that I got it under double switching to where it's this constant torque, this really helped a lot. Now, if I had all 12 coils, it'd be substantial. It'd be double what it is right now. I can only imagine. Then I'll just take this off now. And now we're just running off the capacitor bank. This wire is just going directly to the top motor coils, but it's only riding off of that capacitor right now. But now we're just running off the capacitor charge. So less than 2 watts of power, and there's a lot of torque. Like, it's crazy how much torque there is. Like I showed you in my other video that I butchered, the amount of torque that it has right now is probably half as much, or maybe a little bit more than half, or less than half. I don't know. It's hard to say, but I can tell there's a little bit less in torque because the coils are right on top of each other, and I'm not powering all at once. I'm only powering 3 at once, but twice to make it a constant torque. So it put about 1.2 Newton meters, or Newton meters, NM, whatever that was. Yeah, Newton meters. Yeah, 1.9 Newton meters it was putting out for torque at a constant draw on the coils. But obviously, you can't use that as your working torque. You can, but that's at a 0 RPM like you guys were stating, and yes, that is true. But now I do have a constant torque, and now I can do actual tests because I have a constant torque. It's not pulsing. It's not just a single pulse every time. It doesn't just pulse 6 times, it's pulsing 12 times, which has given me an actual constant torque to work from. So it's pretty good, usable, workable. I mean, the motor, it's a legit good motor now that I have constant torque, like a motor should have. Now I can show you, the amount of. You can see that it discharged enough to where it was causing an arc to the battery from the battery to the capacitor. Because I was putting quite a bit of load on this motor while I was running without any power coming from the battery. But now I can actually do some tests. So we know the input is less than 2 watts because I showed you before when the battery was around 1000 volts, it was pulling 2 milliamps about, and that was at a full load, me holding full resistance on the coils like this. Here we see that it's higher now because I only have 3 coils in series rather than 6 because of how I have the motor ran. So now at a constant load, it is roughly 2.5 milliamps on one coil set, and then this is the other coil set. 2.5. Well, that's right. I need to put this to the battery so we have a constant power because now I'm drawing the capacitor bank down. Sorry, guys. I don't want to be drawing misconception. I don't want that in my videos. I want to be true and legit with all my tests. So now we're running just off the battery pack as a capacitor inline. Alright, so now let's do a full load test. So, yeah, see now it's like double the amount, but a little bit less than double the amount that we had earlier when all 6 coils were in series. now we have 3 coils that are in series on 2 different sets. So that's about the max current, 3.8. So if we say this battery pack was at 1,000, that would be 3.8 watts. And then the other coil set is almost 4 milliamps of current. Let's just say 4 watts. It has a total drawdown of 4 watts. So that's the maximum amount of power input to this motor is 4 watts. And it's actually less than that because the battery pack voltage is only at 970 or 960 when I'm at a full load. So power consumption is still very low for how much torque this motor has for output. Like there's a lot of torque. Like I showed you in the other video, there is torque to this motor, and there's pretty decent amount of torque. I'm squeezing as hard as I can on this shaft. And obviously if I go from the outside of the rotor, I can slow it down easier. God, only if I could have all 12 coils. I know I keep saying that. I'm just disappointed because I can't do a full test. But I'm going to make my next video, I think, I'm going to try to find either a 1 pound weight. I could probably go more than 1 pound. But then I'll put my pulley on here, and then I'll have a string, and then I'll put it down, put the weight all the way down to the floor, and then I'll have the motor pick it up until it gets to the top and see how long it takes and how much current it pulls. And then I could I should be able to get I should get some kind of a power output off of that, like a dynamo, but just a basic version. Because I'm not going to do it off of torque and RPM. I can't do that accurate. Like I can give you how much torque the motor can give at its maximum, and I can give you how much RPM it has at its maximum, but those aren't real stats, as you guys said. So that is something that I can't do. But the pulley and the weight is something I can do. So I will work on that next for my motor to see what kind of efficiencies this thing's got. I'm sure, like you guys keep saying, it's probably not great, but I don't know. The input at a maximum of 4 watts, and for how much torque this has, is quite a bit for 4 watts. Although it is, getting that leverage force with these strong magnets on a 1 foot diameter rotor. So I mean, that's adding, leverage force to the advantage of the motor. But also, the amount of input is very low. Like if I were to buy a motor that had a gear reduction and I had a 4 watt motor and I had it where it could spin at the same RPM of my motor, I might be able to, compare the difference between my motor and the motor that has a maximum of 4 watt input to a gear reduction that is matched to this RPM. That would be the ideal test, in my opinion. But now, I mean, does it pay to go through all the effort of looking for a 4 watt motor with a gear reduction ratio that would match that? I mean, it'd probably be kind of hard to find something that spins at 20 RPM with a 4 watt of maximum 4 watt input. I mean, the thing would be a pretty tiny motor, for one. I mean, the thing would only be like yay big with a gearbox, that'd be bigger than the motor. But anyway, this video is getting pretty long, I didn't realize that, sorry guys. But this is where I'm at the moment, and my next video I'll try to see what I can do with a weight. Or maybe I'll figure out how much weight it can possibly lift. The heaviest weight possible, that might be a good option too. Like, just keep weighing this thing down to see how much it can lift, and then test how long it can take to pull that up to the top in the amount of time. or something like that. But yep, 15 minutes. This is getting long. See you later, guys.